All right, today we will be extending what you guys had learned last week, and it's actually going to combine what you talked about with your exponent rules, um, as well as what we talked about with rational exponents. So if you want to pause the video for the moment and get out both the exponent rules notes, so go find those, or if you want to pull them up on your phone, you can do that too, as well as the notes that I had sent you guys about rational exponents. These notes that we do, like I said, is kind of an extension of that. So you will want to definitely have those out so that when I kind of start using some of the rules and referencing some of the stuff you learned last week, you'll know what you're doing. Okay. So this is essentially more practice with what we did last week, but you'll notice that they look a little bit more complex. And so all I'm going to do is just show you some examples with kind of how to work through them and a way to approach each problem. And then I will also show you, because I know a lot of you may only have the Desmos on your phone to be able to do these problems. So I'm going to show you how you can use the Desmos on your phone to simplify them. So um, let's get right into it. So if you look at this problem with number one, this is more so a review of rational exponents, because notice you have a radical or a root, and then you have a variable with an exponent. So this is just practice with what we learned about rational exponents. So remember, what we talked about is if you have a variable to an exponent that's a fraction, you can rewrite it, but you have to remember that top number is your power and the bottom number is your root. And so the bottom number comes over and becomes the root. Remember, it's cradled in that little check mark. And then you just write your variable over, or your base, whatever that base is. And then you write the top number or the power as the power or the exponent. So with this one, if we had to simplify this, oh, good start with lead. If we had to simplify this one, well, we have to actually work backwards because it's already written as the root. And so I'm assuming they were wanting us to put it in exponential form, because if to be able to simplify it, you'll notice that when we put it in exponential form, it will simplify a little bit easier. And so we actually have to work backwards. So remember, power over the root. So the 24 is your power, the 3 is your root. So when you write it in exponential form or back as an exponent, the power goes on top. So the 24 is going to go on top. And then that's going to be over your root, which is 3. There's a little bit of a glare. So let's see if I can, maybe I'll zoom in a little bit. You can see a little bit better. Oh, man. So if you can't read that very well, it's x to the 24 over 3. And now notice 24 over 3 actually does reduce. 24 divided by 3 ends up being 8. So this would be x. Oh, goodness gracious. This would end up being x to the 8th power. So with the next one, I bet that's a little bit better. With the next one, notice it's also written in radical form, but now you've got a little bit more going on. So what we're going to do first is kind of like what we did with the last problem, where we write it in exponential form, and then we're going to see if it simplifies. Okay, so I'm going to take each part and write it in exponential form. So I'm going to start with the top. So this is the 5th root of y, and then remember your hidden exponents. It doesn't have one, so you write down a 1 for the exponent. So if I rewrite that, think power over root. My power is 1, so it'd be 1 over my root is 5. So there's that one. And then on the bottom of my fraction, I've got the 4th root of y to the 7th. So if I rewrite that in exponential form, well, my power is 7, my root is 4, so it'd be power 7 over root, which is 4. Okay, so now I'm going to look at it and I'm going to see, okay, is there anything else I can do with this? If you think back when we talked about exponent rules, when we did exponent rules, if you have like bases, which notice the base of this one is y, and that one's also got a base of y, and you're dividing like bases, you actually have to subtract their exponents. And so I know how we all love fractions. And so if you are not real great with combining, or in this case, we have to subtract our exponents here, you can always use your calculator. Okay, so I'm going to show you how you can use the Desmos app to help you with that. Okay, so remember, you always end up putting your answer where the bigger exponent is. And so if you're not sure which one is bigger, you can always type it in. Like if I didn't know if 7 over 4 is bigger, then I could type that in and see what that equals. Oh, sorry, I'll just type it in. 7 divided by 4. And let's see, that's 1.75. And then if I compare that to 1/5, which that one should be a little bit easier to compare, that's 0.2. So 7 over 4 would definitely be bigger. Okay, so you always, so that you end up with a positive number, you're always going to start with your bigger number. So 7 over 4 is bigger. So I have to subtract them. So it'd be 7 over 4. And then I type in minus, and I'm going to type in the 1 over 5. So it'd be 1 divided by 5, and it automatically puts it as a fraction for you. Okay. Notice though, it puts your answer as a decimal. If you want to see what the fraction part is, which for these problems you will, you just hit that little fraction button that's to the side right there, and it will automatically change it to a fraction. So whenever we subtract these, we get 31 over 20. Okay, so when I write my answer, remember, whichever one is the bigger number, whichever one you started with, is actually where your answer goes. So my bigger number was the one that was on the bottom. So when I write my answer, so remember it's 31 over 20. When I write my answer, I actually have to put my answer on the bottom. So it's y to the, remember it stays as an exponent, 31 over 20. And then that's when we got, or what we got when we subtracted these. So there's not going to be anything on the top anymore. So remember, you just put a 1 to hold that top spot if there's nothing else that goes on top. And then there's nothing else that will simplify, because this won't simplify because it's not like a regular number as the base. And you have all positive exponents. And so that's as far as you can go with that one. Okay. So we're practicing using our rules. We're practicing learning how to type it in Desmos. And so let's keep going. So with number 3, notice we're multiplying two things, and notice they have the same base. And so the rule with that is when we're multiplying like bases, we have to actually add their exponents. Okay, so when I do that, remember the base stays the same, and then you simply add the exponents. So that would be 1/3 plus 4/3. This is actually an easier one to do without a calculator, because notice when you're combining fractions, if they have the same denominator, or the bottom of the fraction is the same, then you actually can just combine the tops. So since both of them have a denominator of 3, I can just combine the tops. So 1 plus 4 is 5. And then remember, your denominator stays the way it is. And then you can see, can I simplify that anymore? You could write it as a mixed number, but for most of these problems, they just have you leave it as a improper fraction. And so that's as far as we can go. Okay, so just practicing some other stuff with these rules. We're going to head over to number 4. This is one of those exponent rules where you have something and it has an exponent, but then it's to another exponent. That's called power to a power. So if you go and you review that exponent rule, when you have a power to another power, you have to multiply So there's just one thing on the inside here. So essentially, you just have to take that 3 and multiply it times 1/4. And whatever you get would still be the exponent of the y. So 1/4 times 3. When you multiply stuff like this, if it's just a regular number, remember all regular numbers are technically understood to be over 1. When you multiply fractions, you multiply straight across. So this would be 1 times 3, which is 3, and then 4 times 1, which is 4. And so we get 3/4, and that would be the exponent of that. So when I take this to the third power, I get y to the 3/4 power. All right, so this is kind of another example where we have some stuff on the inside to a power. And so this is kind of a step up from the problem we just did. But because we have multiple things on the inside, we have to take this power times every power that's inside the parentheses. So remember, when we have a number, it has an exponent in and of itself. And so don't forget about those hidden exponents. So like this 49 doesn't have a power, so technically it's to the first power. That x has a power with it, so we're good there. The 64 doesn't have a power written with it, so you're going to put a little 1 for that. And then the y to the 8th, it has a power. And so now you have all of this to the 1/2 power. What you do, power to a power, is you multiply every exponent in here, every power, times this power. So this would be 1/2 to the first power, or excuse me, 1/2 times 1, excuse me, and then 1/2 times 10, and then 1/2 times that 8 down there, and then 1/2 times that 1. Okay, so it looks like a mess, but hopefully that makes sense. All right, so when I do that, I get 49 to the 1 times 1/2 is 1/2, x to the 10 times 1/2 would be 5, over 64 to the, well, 1 times 1/2 would be 1/2, and then it'd be y to the 8 times 1/2 is 4. Okay, so then from there, we have to see if anything else will simplify. Well, notice we have 49 to the 1/2 power. If you think about what we talked about up here, sometimes if you rewrite it in radical form, it'll actually help you simplify it. And notice in this case, it actually does help us with this problem. Okay, so 49 to the 1/2 power, if I think power over root, it would technically be, well, 2 is the root, so it would be the square root of 49 to the first power. So 49 to the first power is just 49. And then if I take the square root of 49, I get 7. So this ends up being 7. The x to the 5th I'm just going to bring over. And then all of that is over, well, 64 to the 1/2. That would end up being power over root. So it'd be the square root of 64 to the first. 64 to the first is 64. And then the square root of 64 is 8. And so that's what that ends up being. So I just wrote it over there. And then the y to the 4th will come over. Okay, so then from there, if these two numbers simplified, kind of like how you reduce fractions, then you would do that, but these don't have a common factor. And then the x and the y are different bases, and so you can't do anything else with that. And so this ends up being your answer. Okay, all right, so hopefully that helps with those. So now let's do a little bit of the harder problems that you may see where, again, it's combining some things. All right, so all of that practice that we just did should help with these. So notice with this one, you've got a bunch of powers to a power. Okay, well, when you do this, you have to take each power times that power. So 8 to the first power. So we have to take this 2/3 times every single power in here. So it'd be 8 to the 1 times 2/3 is 2/3. X to the second, it would be x to the 2 times 2/3. And again, you can type this in Desmos if you need to, or you can kind of go to the side you multiply top times the top, bottoms times the bottoms. This is understood to be over 1. So it'd technically be 2 times 2 is 4, 1 times 3 is 3. So it'd be x to the 4 thirds. Okay. And then the y, it'd be 1/3 times 2/3. So again, you can type it in or you can do it by hand. 1 times 2 is 2. 3 times 3 is 9. So it'd be y to the 2 ninths. And now, these don't have like bases, so you can't really do anything there. However, 8 to the 2/3, you will have to look to see if it simplifies. So go to the side, just like what we did with the problem before this one, and see if that'll simplify. So rewrite it in radical form. Power of a root. So the root is 3, so it'd be the cube root of 8. And then now, remember the other way to write this is you could write the power on the outside of parentheses. This is another problem where it'll actually help if you do that. Because if you take the cube root of 8, what number times itself? 3 times gives you 8. That's actually 2. So this ends up being 2. And then it's 2 squared, because I just brought the squared over. And notice 2 squared is 4. So that ended up being just 4. So when you actually write your answer, that was 4. And then the x to the 4 thirds won't really do anything reduce-wise. And then the y would be to the 2 ninths. And that is as far as you can go with that problem. Okay. So then the next problem, same kind of deal, but now we've got negative exponents. So we get to review that type of problem. Okay. So same thing, you've got powers to a power. This 32 has its own little power, so I'm going to put the 1 there, and then you distribute. So same kind of story. So it'd be 32 to the 1 times negative 1/5 would be negative 1/5. X to the, well, negative 10 times negative 1/5. A negative times a negative is a positive. And then 10 times 1/5 would technically be 10/5. But 10 over 5 actually ends up being 2. Okay. So if you realize that right off the bat, you could erase that and write down 2. Okay. And from there, it'd be y to the 1/2 times negative 1/5 if you need to go to the side, or if you need to type this in Desmos, you can do that. So a negative times a positive is a negative, so the answer is going to be negative here. And then 1 times 1 is 1. 2 times 5 is 10. So it ends up being negative 1/10. So now, we did power to a power. If you remember the order that you have to do these things, you do power to a power, then you move negative exponents. And so the next thing I'm going to do is any of these things that have a negative exponent, I'm going to move it to the other side of the fraction. So this one's going to move, and that one's going to move, because remember you have to take the base with it. The x to the second is actually going to stay on top of your fraction. So I'm just going to bring it over. And so when I move the 32 to the negative 1/5 to the bottom, it becomes a positive 1/5. And then when I move the y, it's going to now be to the positive 1/10. Okay. And then same thing as before, if you have a number that has the fraction as the exponent, you have to see if you can do anything simplifying wise. And this will simplify. So when I rewrite that, power over root, my root is 5. So it's the 5th root of 32 to the first power. 32 to the first power is just 32. So really, I'm just asking myself, what's the 5th root of 32? And so you can use your calculator to do that. Or you can just say, okay, what number times itself 5 times gives me 32? And if you kind of think about it, 2 times itself 5 times actually gives you 32. So that would actually end up being 2. All right, so now that I know that, I'm going to copy down my answer here. And then instead of this, I'm going to write down it was equal to 2. And then I have, bring my y to the 1/10 over. So my final answer, because these aren't bases, would be x squared over 2y to the 1/10 power. Okay, so we got one more because this one kind of combines everything that we've talked about. So when you're doing a problem like this, take it step by step. Do not try to do everything at the same time or you're going to get really confused, okay? So when you're doing a problem like this and it has a fraction and it's got a power to a power and all that good stuff, the first thing you want to do is see if anything will simplify kind of easily at first. And then after that, then you could do the rest of it. Okay. So for instance, I noticed that the 16 over 2 will very easily simplify because 16 over 2, well, think about what 16 divided by 2 is. It actually ends up being 8. So if you wanted to go ahead and do that part first, that may help you later, but if you don't notice it until later, it'll still work out, okay? Same thing with these. If you wanted to go ahead and simplify those first to make it a little easier, you can do that. But I'm going to show you how you can do it using our PMS stuff. Power to a power, move negative exponents, and then simplify, okay? So with this, if I notice the 16 over 2 went ahead and simplified, I'm going to go ahead, okay, 16 divided by 2 is 8. And then if you didn't notice anything else, they would stay the way they are, okay? You could technically go ahead and simplify those, but you may end up doing it more than once. Just depends on the problem. Okay, so I'm going to show you one way to do it, and then if you need me to show you another way to do it later, feel free to ask. Okay, so from there, you have a power or a bunch of powers to a power. So just like what we did in all the other problems, this 8 has a power of 1. You're going to multiply that power times every single power that's in that parentheses. Okay, so when I do that, it'd be 8 to the 1 times negative 2/3 is negative 2/3. 1/2 times negative 2/3. Well, positive times a negative is a negative. 1 times 2 is 2. And then 2 times 3 is 6. Notice that will reduce. So if you want to go ahead and reduce it, 2 over 6 ends up being 1/3. So I'm going to go ahead and do that part. And then y to the 5th, well, positive times a negative is a negative. And then 5 times 2 is 10. And then there's nothing on the bottom, so it'd be essentially 1 times 3, which is 3. And that won't reduce as easily as the other one, or it won't reduce. You could rewrite it as a mixed number. And then on the bottom, you have 1/3 times negative 2/3. Again, a positive times a negative is a negative. And then 1 times 2 is 2. And then 3 times 3 is 9. That ends up being negative 2/9. And then also the y would be negative times a negative, which is actually a positive. 3 times 2 is 6. And then that's not over a number, so it'd be 3 times 1 essentially, which is 3. And then notice that one will reduce. So 6 over 3, 6 divided by 3 is 2. Okay, so that's the power to a power. The next thing is if you have negative exponents, you've got to move them. So the only one that doesn't have a negative exponent is this one right here. So that means this is actually going to flip to the top, and then every single one of these things will go to the bottom. Okay, so that's a lot at once. So if you need to move one at a time, you can do that. But I'm going to try to multitask and move everything that needs to be moved. So all 3 of these need to be moved to the bottom. And then this one needs to be moved to the top, and that one will stay with the bottom. Okay, so I'm going to keep it organized. I'm going to move this one to the top first. So the x to the 2/9 comes to the top. And then there's going to be a whole lot of stuff on the bottom. So from here, the 8 to the negative 2/3 will go to the bottom, so it becomes positive now. The x to the negative 1/3 goes to the bottom, and then the y to the 10/3 will now go to the bottom. Okay, and then don't forget that y to the second has to stay on the bottom. Now, if there's anything else that needs to simplify, then simplify it. Notice this 8 to the 2/3, we had actually done this one before. power over root, so it would be the cube root of 8. Remember, it's helpful for that one to write it outside. Cube root of 8 is 2. 2 squared is 4, so that ends up being 4. Notice you have like bases in the x's and you're dividing. So when you divide, you subtract the exponents. So if you use your Desmos with that, if you don't know which one's bigger, again, you can just type them in. So 2 divided by 9, that's 0.222. And then if you wanted to see the 1/3, 1 divided by 3. So this one's bigger, so that's the first one you want to put. So just arrow over, and then you have to subtract them. So since the 1/3 is bigger, your answer will actually go on the bottom. Okay, sorry, you guys can't see that very well. See if I can get that a little bit clearer. Hopefully that's a little bit better. Okay, so it's going to be 1/3, and because you're dividing, you subtract them. So minus the 2 divided by 9. And notice, remember, you can change it to a fraction by hitting the fraction. So that ends up being 1/9. You put that on the bottom. Okay, so we're going to go ahead and start writing our answer. So that ended up being 4. When I subtracted these, my answer went on the bottom. So it'd be x to the 1/9. And then, so we're done with those. And now you've got two bases and you're multiplying them. So you have to add their bases. So you just simply add them. So it'd be 10/3. And then arrow over plus the 2. And then again, change it to a fraction. So it'll give it to you as a fraction. And so that would be y to the 16/3. And so everything ended up being on the bottom. So if you don't have anything on the top, you just put a 1. And so, oh, you guys couldn't see that. Sorry. So that is your answer. So this was a little longer one because we had a little bit of review in there. So feel free to ask questions or anything you need. Have a good day.